We're doing geometry today here at Nick Does Maths. Welcome, I'm Nick. Let's do some geometry. We have a tetrahedron ABCD, slightly deformed. I've done my best sketch here. Now the side length is 1 for each side. ABCD is flat. All right, fine. We're just going to set it that way. And P is the point that is vertically below D. First job is to find the length of P to D. So let's just start with that. Now, I do know that the next question is we need to find the cosine of the angle between two faces. So a good triangle for us to look at here is probably this one. Okay, is probably this one. All right, in red. Let's call this point here E. So one thing we might look at, let's look at the triangle BDE. That one is fairly straightforward for us to look at. All right, BED. That's length 1, that's length 1/2. So we can easily show from Pythagoras that that length there is √3/2. Just a simple bit of Pythagoras. I'm going to be pulling triangles out of this sketch quite a bit. Okay, so that is √3/2. Now, actually, let's try and... All right, so standard fact here for me. All right, A to E is the same length as D to E, because they're all the same triangle. Okay, so A to E is also √3/2. Standard fact that we need to know, or that we should know, is therefore this base here, this center where everything will crisscross, right? If I was to draw the equivalent B to over there, A to over there, C to over there, they crisscross here at this point. That is 1/3 of AE. Okay? That is fairly... you can show it, you can go through it all, but really what we want is... Oh, okay, I've made this quite big, but there we go. But to be honest, this entire sketch is fairly important. So that is √3/6. That is √3/2. So PD squared plus √3/6 squared is 3/36 is equal to 3/4. PD is what's that? 3/36 1/12. So that is 8/12, which is 2/3. Okay. So we want square root of 2/3, √2/√3, √6/3. Okay. So PD is √6/3. Which does make, the reason I've made this sketch quite big is once you've got this triangle, it's fairly trivial. Now, the angle between two faces is just there. That is the angle between two of the faces. It's because that's perpendicular. AE is perpendicular to BC. DE is perpendicular to BC. So part 2, cosine of theta is equal to √3/6 over √3/2, which becomes 2/6, which is 1/3. Hopefully we can see that. Now for the last part. Now for the interesting part, right? The first two bits, not too tricky at all, but this is why I want this nice and big. And get rid of this as well. Right. Bit of intuition. We're going to fit a sphere inside this tetrahedron. Now, it seems fairly obvious that the sphere will be central. So it's going to be, the center of the sphere is going to be on PD. All right, so the center of my sphere is going to be PD. And so it's somewhere here. But importantly, when it does that, the radius will go hit that side there at a right angle, but it will also go hit ABC. So the radius will just touch the face BCD over here, but it will come touch the face ABC at P. So that there is R. Okay. So now we need a few other bits and bobs. Now, this is interesting. That's a right angle, that's a right angle. So we can say that that is root 3 over 6 as well. All right. So that's kind of important for me, because these are just identical triangles. R, you can easily show, because that angle there. Is it completely obvious? Yes. Fairly standard. Yeah. Right. So that does mean then that up here, that there becomes root 3 over 2 minus root 3 over 6. And that length there becomes root 6 over 3, take away R. And now all that's left for us to do is, in that blue triangle, do a little bit of Pythagoras, and we should be okay. So where are we going to do this? Have I made everything a little bit too big? We should be okay. We're just going to drop down to here. So we know that root 3 over 2 minus root 3 over 6 squared plus R squared is root 6 over 3 minus R all squared. So this becomes 3 over 4 plus 3 over 36 minus a half So we end up with this. Hopefully you can see that. And we may end up just, for the benefit of speed, we'll do 3/4 plus 1/12 minus 1/2 minus the 2/3, so minus a third. So let's finish this up here. So R is 1 over 2 root 6, which is root 6 over 12. So that is the radius of the biggest sphere that can fit inside our tetrahedron. A little bit cramped down there, but you got this. Just go zoom, zoom. Brilliant. As always, if you're finding this interesting, useful, stimulating, engaging, fun, please do subscribe, like the video, drop us a comment, all that lovely stuff. Hit the bell so that you know what's coming up next. And from me here at Nick Does Maths, all that's left for me to do is to say thank you so much for watching, and I will see you next time.